Okay, this is the pretest for Unit 7, dealing with trigonometry, and these are questions 6 through 10. Um, Number 6 asks to evaluate the sine inverse of negative square root of 2 over 2. So again, that's saying um, what angle has a sine of negative square root of 2 over 2. Now, of course, if we look back at our sine values for 0, 30, 45, 60, and 90, it's pretty readily apparent that that angle is going to be the 45-degree reference angle. Because the sine of 45 degrees is square root of 2 over 2. So again, the idea is they're giving you the value um, for a sine of negative square root of 2 over 2. And they're saying what angle would have that value. And so the reference angle has to be 45 degrees. Well, of course, since it's negative, we know we're not in the first quadrant. It can't be 45 degrees itself. Um, and so what we have to look at here is the notion of this inverse concept, an inverse function. And if you look at the sine graph, we've presented it a couple times. Sine, as you run from 0 to 2 pi, looks like this. And you should be familiar with that. But since we want a negative value, and we're wanting to make this inverse be a function, in order to do that, we have to restrict the domain. And what we do is we take it into negative space. In other words, we go back 0 degrees and we define the sine inverse from negative 90, negative pi over 2 to pi over 2. And by doing that, we pick up all the values for the sine from negative 1 to 1, and we have one continuous function. That is, we have one continuous graph that, when you looked at the inverse, would not double back on itself. That's to say, when you form an inverse, you make the x the y and the y the x. So if you did that with the normal 0 to 2 pi graph, it would end up looking, right? Here are your x's, here are your y's. And of course, we're reversing those, so it would end up looking like this. Well, of course, that does not pass the vertical line test. All right. So what we do in order to make the inverse be a function is we restrict the domain and the range so that we run from negative uh, pi over 2 to pi over 2, and consequently from, when you reverse the x's and the y's, from negative 1 to 1. Now, um, with that said, this 45-degree angle that we determined the reference angle has to be um, now moves into negative space, and so our answer for this is going to be negative 45 degrees, although we're not going to write it in degree measure, right? We're going to convert it to radian measure. So that's going to be negative pi over 4. All right. So the whole concept here is that with the inverse functions, we want them to be functions. And if we just turn them sideways, if we just make the x the y and the y the x, is typically is what you mean by doing an inverse. On the normal graph that you typically think of from 0 to 360 degrees, that inverse will not be a function. And so we restrict the domain so as to end up with something that is a function and does pass the vertical line test. Number 7 is more straightforward. It's back to evaluating the tangent of 3 pi over 4. And tangent of 3 pi over 4 corresponds to, if you want to use degree measure, tangent of 135 degrees. And 135 degrees, of course, lands in the second quadrant. There's 135 degrees. And so our reference angle is the difference between the horizontal, which is 180 degrees, and the 135 degrees. And so your reference angle is 45 degrees. And then if we just consult our table or our unit circle or whatever way you are doing the values for your trig functions, we have 0, 30, 45, 60, and 90. And corresponding values of 0, square root of 3 over 3, 1, square root of 3, and undefined at 90 degrees. Well, the reference angle is 45 degrees, so the tangent of 135 degrees is going to be the same as the tangent of 45 degrees, except that we're in the second quadrant, and in the second quadrant, we know the tangent has to be negative. So the final value will be negative 1. That is to say, the tangent of 45 degrees is 1, and we know it's negative because we're in quadrant 2 right here. So there's another example of how those evaluations are done. Still another one, question number 8. Find the value of the sine of 5 pi over 3. And sine 5 pi over 3 would correspond to the sine of 300 degrees if you do the conversion, right? If you multiply by 180 and divide by pi, that would correspond to 300 degrees. So a 300 degree angle, a little picture of it, there's 90, there's 180, there's 270. So 300 would land in the fourth quadrant. There's 300 degrees. And of course, a full rotation is 360 degrees. So what's your reference angle? The reference angle is always the difference between the horizontal and the terminal side of your angle. So the reference angle here is 60 degrees. Now, for the sine function, 0, 30, 45, 60, and 90. Sine of 0 is 0. Sine of 30 is a half. Sine of 45 is square root of 2 over 2. Sine of 60 is square root of 3 over 2. And the sine of 90 is 1. Well, we have a reference angle of 60 degrees. So there's going to be our value. The sine of 300 will be the same as the sine of 60. Except since we're in the fourth quadrant, first quadrant, second quadrant, third quadrant, since we're in the fourth quadrant, our sine has to be negative. With the sine of 60 being square root of 3 over 2, we obtain a final answer of negative square root of 3 divided by 2. All right, so there's question number 8. And so we'll clean this up and get to 9 and 10. Slide up the page a little bit here. Find the exact value. Okay, now here again, we have a cosine inverse, right, of a negative square root of 3 over 2. So if we take care of the reference angle first, right, so think about cosine, and somewhere or other you need to commit to learning the values for the first quadrant angles. Cosine of 0 is 1. Cosine of 30 is square root of 3 over 2. Cosine of 45 is square root of 2 over 2. Cosine of 60 is a half. And the cosine of 90 is 0. Well, with an identifiable square root of 3 over 2, we know that we're talking about a reference angle of 30 degrees, or pi over 6 if you want to convert it to radians. So the thing is, it's negative. And if you think about the cosine graph looks like this as you run from 0 to 2 pi, 0 to 360 degrees. And now if you think about, again, the idea of this thing being an inverse function, what's going to happen if you make the x the y and the y the x? What's going to happen when you form your inverse? Well, as long as we restrict it to right here, only 180 degrees, only uh, pi radians, will be fine. If you took that graph and turned it sideways and ran from 0 to 180 degrees, it would look like that. The positive values here, you would see over here, right? This point right here, which is at 0, 1, would now be over here at 1, 0. And correspondingly, all the other points would be moved. And you can see that this graph passes the vertical line test. So as long as we restrict the domain to go from 0 to 180 degrees, we will have an inverse function. So with a reference angle determined of 30 degrees, all we need to do is put that in that second quadrant. So where's 30 degrees in the second quadrant? Well, if you draw up 30 degrees as a reference angle in the second quadrant, here's 180 degrees. And so 30 degrees in the second quadrant, the difference between 30 and 180 leads us to a 150 degree angle. And from there, all that's left to do is convert the 150 degrees to radians, and that turns out to be 5 pi over 6. All right. Now, maybe there's a question about how do we convert 150 degrees? How do we convert that to the radian scale? Um, and since we already said that to go from radians, right, to degrees, we said the technique was to multiply by 180 and divide by pi. Then to go the other way, the technique is going to be to multiply by the pi and divide by the 180, right? If going from radians to degrees, you multiply by 180 and divide by pi, then going the other direction to go from degrees to radian measure, you're going to multiply by the pi and divide by the 180. So that gives us 150 pi over 180, and then multiplication there, 150 times the pi, and division by the 180, we can reduce that, and it's pretty obvious that that reduces to 5 pi over 6. So your answer for question number 9 would be 5 pi over 6 radians. One more to do, question number 10, and it's find the exact value of the tangent of 11 pi over 6. And hopefully this type is easy. Um, Tangent 11 pi over 6, the first thing we'll do is change the 11 pi over 6 to degrees. That's a radian measure there. And you'll always be given radian measures. If you convert them to degrees to make it easier to work with, that's fine. It's a good idea. Works well for a lot of students. Just make sure you multiply by 180 and you divide by pi. Well, of course, the pi's cancel, and we can actually do a little bit of canceling between the 6 and the 180. That'll go in there 30 times. So that corresponds to 330 degrees. So they're asking us for the tangent of 330 degrees. And so if you draw up a picture of 330 degrees, starting on the positive side of the x-axis And of course, rotating counterclockwise, there's 90, there's 180, there's 270, 330 degrees, just short of a full rotation. 330 degrees lands in the fourth quadrant and gives us a reference angle measured to the horizontal of how many degrees? Well, again, the full rotation would be 360 degrees. So the reference angle is a 30-degree reference angle. So the tangent of 330 degrees is going to be the same as the tangent of 30, except we're in the fourth quadrant. And what do we know about the value of tangent in the fourth quadrant? Well, in the fourth quadrant, tangent is negative. Then, if we just consult our reference chart, 0, 30, 45, 60, and 90, and 30 degrees has a value of square root of 3 over 3. And so our value here is going to be negative square root of 3 over 3. And that's what you'd put in your answer space. So there's the pretest done. Get back to us. Let us know if you have more questions or need more help with any of the topics. We'd be glad to help you out.